Hello, everyone, and welcome back to another session by TalentSprint. I hope you all are doing great, and I received some really good feedback on the last two sessions that they helped you a lot. And most of you in the last 2 to 3 sessions have mentioned that you want a session on database or SQL, DBMS. So, in today's session, I have come up with the topic top 6 important concepts in database management system. So all that we are going to do today is talk about databases. No C, no C++, no Java, only databases. And we will touch base on 6 important concepts in database. All right. So let's get started. Let me see who all have joined us today for the session. We have Shravani, Hari, Nikhil, Anand, Suganya, we have Govi, we have Rahul Kumar Yadav, we have Vikram. Hello everyone. I hope you are having a really nice day, really nice month, and I hope you get a lot out of this session because the 6 concepts that I'm going to talk about in today's session are like very elementary concepts of database. So all in all, database is not a very vast, it is actually a very vast topic, but the basics that you get to learn in engineering in your database management class, RDBMS class, are very easy to understand. So there are a few fundamental topics that if you learn about database, everything else automatically becomes very easy. All right. So in today's session, we are going to look at 6 of such very elementary, easygoing topics which sometimes confuse people. See, database is nothing but a simple table, say Excel sheet, in which you store all your data. Let's say you are working in a bank. You want to store the details of all the bank accounts that are created in the bank. You put it in an Excel. And then there are details of employees. So you collate all the details related to employees, you put it in another Excel sheet. Then you might create an Excel sheet of all the dependent people, say my dependent or co-signer people. All those go in separate Excel sheet. So all of these things, all of these details that you create or that you collate form the database of a particular, in our case, banking enterprise. Let's take another example, say Flipkart. All right. So Flipkart, what it does is it sells products to consumers. So what do you think the Flipkart database would look like? What all things a Flipkart database would have? Give me some quick responses on, say, one off the top of my head is, it will have the details of the products that are present on the Flipkart for sale. So this product, this is the product ID, this is the price of the product, this is the discounted price of the product, etc., etc. So definitely there is a product schema in the Flipkart database. And this is very abstract level. It will have details in a very detailed level. I'm just talking about the top level, what comes off the top of your head. So what other things do you think a Flipkart database would have? Meanwhile, we have Arun, we have Vikram, Lokesh, we have Sanjeev, Shravani, Raj, and we have Rajiv. All right. So any one of you, what do you think the database would look like? What other things it would have? So one more thing that comes to my mind is the Flipkart database would have customer details. Since you log in to Flipkart to buy something, right? So your details, your address, your phone number, your name, your if you have saved your bank account details, so your bank account details would also be saved in their account, right? What else? Rahul Kumar Yadav says real time. Rahul, what do you mean by real time? I'm asking about what like tables would a Flipkart database have? Hi Rajesh, hi Vimal. Naman, we are today going to talk about database management system, the 6 important or the 6 very fundamental but yet difficult to understand concepts of database management system. Shravani says database consists of tables. Yes, database consists of tables, and these are the tables that we are talking about for this example. So let's say Flipkart is our database that we are looking at. The table, one table would be product, one table would be customer. What more tables can you guys think of? Arun Raut says customer details in all products. Mayuresh also said that. Shravani says transaction table. That is a very good point, Shravani. Flipkart database would also have a transaction table. So it will combine, say, this person with this person ID from the customer table has purchased this product from the product table, and then it will have the transaction details. So he ordered on so and so date, and the order arrived on so and so date, and the price at which the order was sold was the discounted price. If there are some grievances, then the grievances, all those details would be there, right? Then customer products item. Lokesh says customer products items, etc. Lokesh, when you say products, items automatically come in that product table, right? There won't be a different table for items. Yes, ATM machines also use database, but that is essentially the bank database that they are referring to, right? Okay, apart from the, see, we have seen product table, we have seen customer table, there will be one transaction table, there can also be one review table. So the customers who like the products or who don't like the products give their reviews on the product, right? So whenever you open Flipkart, you scroll down, you see this product is 4 rated, this product has 5-star rating, this product has so and so comments. So all those can be maintained in a separate table. Now what more can be done? See, there are different sellers selling their products on Flipkart, right? So sometimes when you want to buy a product, it gives you options. You want to buy at this price from this seller, or at this price from this seller. These sellers are verified by Flipkart, so all the seller details can be another Flipkart table. So like this, when you operate a, say, business, you figure out all the details that you will have to store, and all of that together combine to form your database. So in the case of Flipkart, all these things, all these tables combined together will be referred to as the Flipkart database. Now, as and when the customers keep growing, the database keeps changing and updating and growing, right? So that is a basic real-time example and definition that I can attach to a database to make it very clear. Okay, this real-time example, Flipkart, this would be the database. So similarly, you can think of, say, Book My Show. Book My Show will also have a database at the backend. So what will be the database of Book My Show look like? Think about it after this session, right? I'll give you a few more examples. Say, what else can we talk of? We have seen Flipkart, we have seen Book My Show, the banking system, which is pretty common, schools, colleges, libraries, that is also pretty common, that every book talks about. Try to connect it to real life situations that will make you understand it more easily, right? Say Paytm. Everybody these days uses Paytm. So what would the database of Paytm be like? What all details? It will be as close to a bank as it can be, right? So what all details Paytm would have? Since from bank, you don't pay directly to the customer, correct? You only pay it to the added accounts that you have in your bank account. But Paytm, you can pay to anyone and everyone. So what would the database of Paytm look like? And so you can figure out real life situations where database is, and everything at the backend is a database. So you can think of situations like that and try to relate it to database, right? Let me see, some of you are throwing off really nice inputs. Vartha says include SQL interview questions. Oh, okay, fine. I'll try to take it up in one of the next sessions, interview questions, but this one we'll keep to the concepts, okay? Then we have car transaction order tracking. Very correct. Uber, let's say, if you are booking a cab, it would have a database at the backend. What would be the database of Uber or Ola? Any cab booking system, right? what would that look like? So all these things, just think of after the session, try to come up with ideas. Okay, this will be one table, this will be one table. Like in the case of Uber, who has suggested? Naman Mishra suggested car transaction order tracking. So if you're booking a Uber, what all tables would be in the database? Definitely there would be one table of car. There can be one table of car owner. There can be one table of users who are booking cabs on Uber, right? So think of all these details. There can be again one table of transaction, like this user booked this cab on so and so date from here to this location. All that transaction can be one table, right? And all the tables are related to each other. Lokesh mentioned a point that all the tables are related to one or more of the table. That is why they combine together to form a database, correct? So only the table that is storing car information is of no use to us. We need the whole transaction, that this customer from the customer table has booked this car from the car table from this location to this location on this date, and this is the price, right? Then only the car table and the customer table becomes useful after we combine them together to get this transaction, correct? So all the tables are kind of related to one another in one or other way. All right. Address table is another thing that you can make separate. Say in Flipkart, if you are storing customer information, the address information doesn't have to be in the same table. It can be a different table from which you are just calling the address details to your primary customer table, right? Someone has suggested Big Basket. Nikhil gave a very nice example, Big Basket. What would the database of Big Basket look like? Now it will be pretty much similar to Flipkart, because they are again selling groceries. Flipkart is also selling stuff, Big Basket is also selling stuff, but the details in the table will be different for Big Basket than for Flipkart, correct? E-banking, right? Bola says, am I late? To you're not. We have just started discussing real life situations where every real life example database is used. So we are just discussing how to relate to what you see around, that so that it becomes easy to understand the whole function of databases. IRCTC website, Lokesh has suggested, is a very good example. Then Rahul pointed out Paytm customer details and transactions, right? And then location can be one. Prateek says, please put this video on channel. Prateek, this video will be on the channel after it is live. All the live sessions are always available on the channel. You can go back and watch them. Mayuresh says, explain normalization deeply. Mayuresh, normalization we are going to talk about in the session today, but I'm not sure if we'll have time enough to do it deeply, because normalization generally takes at least 2 to 3 sessions to explain in whole detail. First normal form, what is second normal form. So we might not go into that detail, but I'll explain what is normalization. Aadhaar card database. So you guys know of all the examples, right? Just when I'm going to start the session, just try to relate it to all these real life examples, how everything would work in the real life example, right? Rahul Kumar Yadav has just pointed out IRCTC, social network, and Red Bus, right? So you know the examples, as in when we get through the slides, just try to relate to these examples and see, okay, this is how the data fits in, correct? Okay, so let me jump on to the first slide. So this is what we are going to talk about today. We have asset properties, the first point. We have types of SQL statements. We are going to look into ER model, that is entity relationship model. We are going to talk about normalization, which, like I said before, we will not go into details of what is first normal form or second normal form, but we'll get to know what normalization is. All right. Then next we have SQL joins, which is very important. If you are working on tables, you need to know which tables to join when. Say in our case, we joined in the latest example that we discussed, we joined customer table and product table to make the transaction. So this customer purchased, say, this product from Flipkart on so and so date at so and so price, right? So we'll discuss joins and then we will discuss constraints. These are the 6 things that we are going to discuss in the session today. So let me start off with the very first, ACID properties. So anyone knows what ACID means? Everyone who would have read database in college would know what ACID refers to. What's the full form of ACID? I'll give you a minute to just drop in your answers. Rahul, I have not refreshed on what the current AMCAT syllabus is, but these are like most of the topics that would be asked. So Revati has started replying atomicity, consistency, integrity and durability. And that is totally correct. Shravani is also replying. Shubham Modi has replied atomicity, consistency, isolation and durability. Right. So yeah, Rahul Kumar Yadav replied. Cool. So you know what the full form of ACID is. So let's take a look at the ACID properties one by one. Okay. So a transaction, what is a transaction? And when you talk of a transaction, what do you mean by it? It is simply a group of tasks. A transaction consists of a group of tasks. Task 1, task 2, once that is done you do task 3, then you do task 4, and once all these tasks are complete, your transaction is complete. So a transaction is one set of such tasks. You divide your transaction into parts and each task cannot be further divided. So this task has to completely execute, say, before the next, or 2 of these tasks have to execute, provide their input to the third task, and then third task executes, provides its input to the fourth, and this completes the transaction. So it could be any set of flow like this, either task 1 to task 2, 3, 4, or 1 and 2 are parallelly executing, they provide input to 3 and then 4. Any such group of tasks is referred to as a transaction in a database. Now, a transaction is supposed to have these 4 properties: atomicity, consistency, isolation, and durability. So let's quickly take a look one by one at all these things. So by atomicity, we mean that either the entire transaction takes place at once or not at all. So let's say you start with task 1. Let me just change the color to highlight. Let's say you start at task 1, you do task 2, and suddenly some system error happens and you are not able to do task 3 or task 4. It stops after task 2. So what atomicity says is that either you complete 3 and 4 and then commit the changes after that, right, after 4, or you roll back and go back to 0 state, right? You cannot be midway. You cannot do 2 tasks and leave 2, or you cannot do 1 task and leave 3. If you are stuck midway for any reason, for some system error, for some user error, for whatever error, you cannot leave a transaction in between. You have to either roll back to the original state or you have to somehow continue and complete the transaction. So every transaction that is done on a database has to maintain this feature that is referred to as atomicity. Correct? So rollback, or sometimes also referred to as abort the transaction. So go back to the original state. And if everything is done, commit your changes to the database. Correct? So that next time when you read the database, you get to see the changes that you have done in this transaction. Let's call it transaction X. Okay, that is what we mean by atomicity. Raj has mentioned transaction means whole task will be executed or either roll back, which is correct. Atomicity means that's not what transaction means, Raj. That is what atomicity means. Atomicity means either the whole transaction will execute, not the task, the whole transaction will execute, or the whole transaction will roll back. We cannot be midway. Okay. Now consistency. Consistency means, let's say before task 1, okay, you had 500 rupees in X person account and you had 200 rupees in Y person account. So the total was 700. Now let's say you do a transaction of transferring 200 rupees from X to Y. Okay, that is your transaction. Now what consistency means is that before transaction, your total was 700. That is the total value of the database. After completing this whole transaction or this whole transfer of 200 rupees from X to Y, X will be left with 300, Y will get 400. Correct? So after the transaction also, the total amount or the state of the database should be same as the previous. There cannot be any deviation. Say you are transferring, you deducted 200 rupees from X. So X is left with 300. But before you could add 200 to Y, your system crashed. Now that means you are in this middle state, halfway through your transaction. You read the value of X, you subtracted 200 from X, but before you could read the value of Y and add 200 to Y, your system crashed at this point. Now, this is again consistency. So once you do the complete transaction, your previous state that was 700 should be same as after the commit, that is 700. That is what we refer to as consistency. Alright. Now next one is isolation. What do you mean by isolation? Isolation means concurrent execution of transactions. Alright. What does that mean is, let me show you. Okay, don't get overwhelmed with all the colors. I'm just using different colors to stress on different points. So right now we are talking about isolation. So isolation means that these two tasks, task 1 and task 2, have to run in isolation from these two. You cannot execute together. You cannot subtract 200 from X and at the same time add 200 to Y. Let's say, let me give you another example which will make isolation more clear. Say you have to, I think this is not visible, let me change the color. Okay, say you have X minus 100. You have Y minus 50. And then you have Z which is doing X plus Y. Okay. So what you cannot do is, say you did this and then you go to this third transaction, Z is equals to X plus Y. That cannot happen. These two transactions have to run in isolation from this. So you execute X, parallelly execute Y, delete the value of 50 from Y, and then only you can go to Z in isolation. That is what we refer to as isolating transactions from one another. So this becomes 1, this becomes 2, this becomes 3. Okay? One transaction doesn't interfere with the other. That exactly Anubhav has put in. That is called as isolating the transactions, so that this transaction does not interfere with this transaction does not interfere with this. Okay? And the last one we have is durability. So what does durability mean? It simply says that even on system failure, changes that you do to your database are persistent. Okay, so you read the value of x, you make some changes to the value of x. Even if there are some system issues or something, some error occurs, your database should be durable. Either it should roll back or it should commit, but whatever changes are made, they should be saved back to the database. You cannot say do changes in your transaction and don't commit it back. The commit is a very crucial point of a database, because next time when you read the value of x from database, it should be able to tell you whether it is correct or not, right? So your database should always be durable. And that concludes our asset properties: atomicity, consistency, isolation, and durability. And like I gave the example before, now you can put all these points to the examples that we have discussed initially. So how does atomicity happen in case of big basket, or how does consistency happen in the case of red bus or cab booking, etc. So try to relate these points to the real life examples that we have discussed. That will make understanding it all the more easy. Okay. So next up we have asset properties we have discussed. Now we will go talk about type of SQL statements. Okay. So SQL statements are broadly classified into 4 categories. Shravani says, please explain once again asset properties. Shravani, that's going to take a lot of time, but let me just highlight it for you. Atomicity means that the entire transaction takes place at once. So if your transaction consists of 4 parts, task 1, 2, 3 and 4, atomicity says that all 4 should execute together in one part. You cannot execute 2 tasks and leave the 2. Okay. Consistency means that your transaction state of the database should remain the same before the transaction and after the transaction. So just check, consistency is in blue color. So before transaction sum 700, after transaction also sum should remain 700. So if you are transferring 200 from X to Y, before the transaction happens the sum is 700, after the transfer happens also sum should be 700. That means consistency. Isolation means that every transaction is independent of each other. This transaction should not hamper this transaction, or this transaction should not mix up with the previous transaction. Okay. And durability says that whatever you do in your database transaction should eventually be persisted to the database, because without that there is no point of doing all the work. All right. Okay. So moving on to SQL statements, we have first one, DDL, data definition language. So can some of you point out what are the commands that are part of data definition language? So if you have read DBMS, you should be able to give me some commands that are part of data definition language. Or what does these commands do that are part of data definition language? Revati says create, alter, rename. Sami said create, alter. Okay, so data definition language means the commands that are used to define your database. Right, so when you're starting to create a database, these commands are used to define the database. So create your database. Say you want to change something in the database, so alter database. Then you want to drop database, or say you want to create a view, so create view or drop view. All these are data definition. Remember this word, definition. which has to do with creating your database or defining your database. All right. Now next up we have data manipulation language. So what are manipulation language commands? Revati says DDL actions are auto commit. Like you're creating a database, it auto commits. You don't have to commit it. Samir says alter, truncate, delete. Yeah, Revati rightly pointed out, delete is DML command. Right, insert, delete, update. So all these, anything that lets you change your database, right, those are manipulation commands. Okay, so essentially insert, update and delete. All right. Now Samir mentioned select. Okay, some people or some books or some articles would call select as your data manipulation language, part of data manipulation language. But recently it has been started to refer as data query language. Okay. So sorry, what you do from select statement, you query your database, right? You don't manipulate, you're just checking select say x row y column for so and so properties. You're querying the database, you're not changing anything in the database. So select falls under data query language, DQL. Okay, next up is data control language. Now control means you have a database, right? Now you don't want everyone to get all the access to the database. Some people might corrupt your database, so you have to password protect, you have to give access to a few people. Let's say the people you give access to are no longer working on the same project, so you might want to revoke their access. All these things come under data control language. You are controlling who all can access your data, who cannot access your data, in what capacity someone can access your data. All these things fall under the data control language. All right. So what are the commands for data control language? We have, say, something known as alter password. This is part of data control language. Or grant, that gives access for the DB, is part of data control language. Or say revoke, you don't want someone to access your database anymore, you revoke it. Okay, so that again becomes part of data control. All right. Does drop and truncate come under DML? Yeah, drop and truncate both will be part of DML. DDL is only, sorry, drop is part of, like I said before, I have mentioned, yeah, drop is part of definition. You are dropping a view or you're dropping a table. That is part of DDL, not DML. Okay. All right. Hi Govind. Yeah, so let's move on. Finally, we have transaction control commands. Okay, so the transaction control commands make sure that whatever transactions are happening, they take care of, they are completing properly or not, occurring following the asset properties of atomicity, consistency, etc. or not. So those are all the transaction control commands. All right. So that was for SQL statements. Now you might get questions. This is just an overview of what are SQL statements. Okay, you might get a DB and say your interviewer asks you to write a query to extract the list of employees who are from particular location and who receive salary greater than this, and say who have completed 7 years in the organization, right? So you will have to write a select query, that is data uh, query language, right? You have to write a select command to do that. Or say the question goes like, you have two tables, you want to give access to two new people in your company, what will you do? So you will go to data control language, right? So keep in mind what each one of these does, and then writing the query on each of these will become way more easy. So right, data definition, say your interviewer says, we started by creating a table which we no more use. So the table that we don't use, we need to drop it. Drop. What we are doing in this process is we are changing the database. We don't need a table, we are changing our database. So we need a database definition language, and then you can connect it to the command that is going to be used, that is drop. Okay. Anubhav Pasi mentions select with where, right? So select with where. Select again, guys, is used with a multiple other commands. So select with where, select with aggregate functions. Say you have to calculate maximum, minimum, subtraction, addition, all those things. So select works with group by, when you have to group certain details. Select is one statement that works with a lot of other query constructs. So make sure you know in a bit more detail about each one of those, right? But at abstract level, if you know which command falls under which category and what it does, it becomes easy to relate to the question that is asked in the written exam or in the interview, because then you know, okay, I have to alter database, or I have to do a query on the database, and then accordingly you can start off your solution. All right. Okay, so moving on to the next one. ER model. What do you understand by ER model? Any ideas? What does ER stand for? Entity relationship model. That is correct. Okay, let me start off by giving more details. Say you want to represent your database. Let's take off with a very simple example of you studying in your college, right? So your college database would have some details about you. So before you put anything into relation schema from ER model, you generally move things to relational schema. Now in relational schema, what happens? You create these table structures. So say this is a student table with this ID or name, and these are the details. Okay, 1, 2, and so on. So this representation is known as relational schema. Now ER model is what? ER model is a diagrammatic representation. So before you start creating your database, you do a diagrammatic representation to make sure that everything is happening correctly. So what do you do in the this diagrammatic representation is, you have all these boxes to represent few things. So say entities will be represented like this, attributes will be represented like this, some conditions or relations will be represented like this, right? Then you also have different lines. So single line means this, line with an arrow means this, a dotted line means this. All these notations are present to create the ER model. Starting with a very simple, say, student table. So you are creating a student. Now what all properties a student has? ID, name, right, address. Then you can also have say phone number, contact person in case of any emergencies. Every student can have a contact person. So these are all the details that you fill in your registrations forms, right? Blood group, certain colleges can ask for, and then which batch are you part of, right? All these details and lots more can be associated to student. Now similarly, you can also have something known as course, right, for all the courses that are in the college. So you can have a course ID again, you can have course title, you can have head professor for the course, correct, and you can have, say, duration for the course, right? Now this, once you have drawn, you can replicate it to any other condition or situation. Say, like we talked about, the first example that we talked about, that was Flipkart, right? So say Flipkart, you are trying to store the information of a customer. So in that case, the student will become customer, right? And everything will remain the same. A customer will have a ID, name, address. Batch will not be there. So a few properties might change depending on which which situation you are putting it to. So batch might not be relevant for a customer. Phone number will definitely be there. Contact person might not be relevant. Okay, blood group you don't need of your customer. So for customer, what else you can have? You can have bank account details. Okay, so those are the things that if your customer has given some reviews, so you can have the reviews, right? So depending on the situation that you are modeling it for, a few things might change, but essentially stuff remains the same. Okay, this representation of your database is known as ER model. So you also specify that each student can have one or more course. So you join the student to this course. Okay, pardon me, I couldn't draw a straight line. So you join student to course, right? Similarly, say address, you don't want it as an attribute, you want it as a separate table altogether. So address, then you have PIN, you have city, okay, you have state, all these attributes, and then student joins to this address table. That is also one way of doing it. Instead of putting address as an attribute to student, you can put address as a table and then relate to it. So this diagrammatic representation before you start creating your actual relational schema is known as ER model. Okay, so the ER model defines the conceptual view of a database, and the diagram mainly comprises of entity set and relationship set. So like we saw here, this is the entity set, and the relationship between this entity and another entity is referred to as the relationship set. Okay, a database set can be modeled as collection of entities, relationships. Now entity is an object that exists and is distinguishable from other objects. So for example, a person or the details of the company can be one entity. Like for example, all persons having an account can be one entity. Okay, now attributes can be of different types. So we saw student has different attributes. So we can have a simple attribute, we can have a composite attribute. So address, for example, can be a composite attribute. So it consists of more than one things. Okay, it consists of PIN, it consists of city, it consists of street, it consists of landmark, right? It consists of state, all these things. So composite attribute. Derived attribute is an attribute that can be derived from another attribute. Then we have single value attributes like ID can be a single value attribute, say 101, 102. We have also multi-value attributes. So name can be a multi-value attribute, which is first name plus last name. So full name becomes a multi-value attribute. Okay, so attributes are of different types. Fine. Okay, now relationship set. Association among entities is called a relationship. Like I said, association between student and his course, right? Association between a patient and a doctor. Association between the Uber car and the passenger of the car. All these things come under relationship set. Okay? So relationship can be one-to-one, one-to-many, many-to-one, many-to-many. Now, giving you an example, a doctor can have multiple patients. So patient 1, patient 2, patient 3. So this becomes one-to-many relationship, right? Then say many-to-one relationship, you can think of an example like that. So multiple products, say product 1, product 2, product 3 can be bought by a single customer. So there can be a many-to-one relationship, right? Many different products can be bought by different customers as well. Correct? It can be a many-to-many as well. So depending on your requirements and the specifications of situation, you can decide whether you want the relationship to be a one-to-one, a one-to-many, a many-to-one, or a many-to-many. Different type of relationships. Okay? Now on to normalization. So someone asked about normalization. We are just quickly going to touch base with what is normalization. Okay? So when you say normalization, if a database design is not perfect, it contains anomalies or referred to as errors. Now normalization is a method to remove all these errors and bring the database to a correct, consistent state. Now how do you do that? Number one, you minimize redundancy. There should not be duplicates in your database. Number two is minimizing insertion, deletion, and update anomalies. Now, what do we mean by insertion, deletion, and update anomalies? Say, you are updating one record. Let's say student record. It should not happen that after updating 3 attributes, 2 are left unchanged, which will lead to half of the data is previous, half of the data is current. Lead to an inconsistent state. That is called an update anomaly. Right? Insert anomaly simply means if you are inserting a new record, don't leave half details unfilled. Let's say this is a primary key, you will get an error. But if it is not a primary key, you might not throw an error, but still your database should be in a consistent state. Alright? So removing these anomalies and redundancies from your database and making it perfectly correct so that anytime anyone checks anything in your database, the output always comes out correct. It is known as normalization, and there are multiple forms to normalization. We have first normal form, second, third, fourth, fifth, and someone just pointed out on the chat that we have BCNF also. I'm not going to discuss all this in this session. Maybe the next session I can take upon normalization next Thursday, because normalization takes a lot of time to explain, guys, and we are already running out of time. So normalization in details, I see most of you have asked me questions on details of normalization. We have Akash asking 1NF, 2NF, right? So let me just say that normalization, since many of you are asking, I'll do another session on the details of normalization. All right. Meanwhile, Lokesh is asking, what is the use of ID in each table? Is it mandatory to write first column as ID? Lokesh, it is definitely not mandatory to write first column as ID, but uh, it is good to have a unique column, something that can uniquely represent each row of your table. So let's say if you are making a student database, there can be two Akash, there can be two Lokesh for that matter. So you need a unique ID to represent each person, right? Now that can be student ID, that can be a consumer ID, customer ID. Simply the idea is you have to have a unique ID to represent each row of your table. That is why an ID column you will always find in every table, until unless it is a consistent table, right? That's not going to change. Say in your Flipkart database, let's say you have to store, you have made a table of cities to a state. Now that is not going to change. You don't have to have ID in there. So let's say when you select location where you want your product to be delivered, if you say Hyderabad, the state currently comes up as automatically comes up as Telangana. So that is a static table. If your table is static, that is not going to change, that you are not going to add more and more, then you might not need to have an ID. But if it is not static, having ID is a very good idea for your table. Okay? Akash, yeah, 3NF and BCNF. Okay, I'll like I said, Akash, we'll take up normalization in more detail in next session. How can we join two tables using common ID as primary key with an array relationship? Deepika, let me just quickly move to the next slide that will give you some idea, maybe not in as much detail as you have asked right here, but will give you some idea. Right, so normalization, first, second, third, fourth and fifth. Basically, the simple purpose of normalization or the use of normalization is just to make your database correct, your database relevant, your database consistent. Okay? And moving on to SQL joins, what Deepika just asked. Okay? What do we do in SQL joins? So we have different type of joins. We have inner, outer, left outer, right outer, cells join, and much more. So what does join simply do? It combines rows from two or more tables based on related columns between them. So since I've taken Flipkart example since the very beginning, let me continue with that. So we have customer, ID, name, etc., the details. And let's say we have product. Okay, and then again product ID, product name, product price, okay. Let's say we have these two tables. Now how does inner join, outer join, self join, etc. work? Now you might not need all type of joins in one particular case. So let's say in this one, if we have to find out all the customers who have bought a certain product, think of whatever, not particularly this example, but any other example. Just think of both your tables that you are talking about as these two boxes. Okay, so this is table 1, this is table 2. Now you want to find out what is common between these two tables. Okay, based on some column that is common in both. So say a customer has purchased some product, so there will be a foreign key here, product ID, associated to this customer, whatever product he has purchased, right? Now with this product ID and this product ID, you can join the two tables, Correct? There has to be a common column to join two tables. So the idea of inner join is to find this common area between the two tables. Similarly, the idea of outer join is to basically find the complete combination of table 1 and table 2. How many possible combinations can be formed? In this case, what you get is, say we have C1, C2, C3, P1, P2. So in outer join, what you will get is C1, P1 is one row, C1, P2 is one row, C2, P1 is one row, C2, P2 is one row, C3, P1 is one row, and C3, P2 is one row. So outer join gives you all the combinations of both the tables. Okay. Now left outer join, what you will get is all the contents of this table plus the common. Okay. Similarly, right outer join does the same other way around. All the contents of T2 and the common. Or the other way to say it is all the common contents plus T2 remaining. Alright, that is right outer join. Okay, and self join is when you join T1 with itself to get some details. That is called self join. Okay, how can we join two tables using common ID as, okay, that Deepika I mentioned, we'll talk about later. Same column should be there in both tables to join. Yes, Lokesh, same column has to be there in both tables to join. Otherwise, there is no common thing to do the join process. Right? There has to be one thing that is common to both. So, say in this you have products purchased, customer. You have, customers, you have one table as one column, let's say as products purchased. And you want to know, some transaction that you want to join both these customer and product together. So the product purchase and the product ID of the product column will come in together and they will help you figure out these details. You want an outer join or left outer or right outer, etc. Okay. Next up and final one, SQL constraints. So constraints, my bad, this is SQL. Constraints are rules used to limit the type of data. You don't want all garbage sort of data going into your SQL constraints, right? Let's say if you have an email column in your SQL table. So you can constrain it that there has to be a dot, there has to be a @ there has to be a .com, right? You can mention these details. Let's say you have to write the price of a product. You can restrict that it is going to be a numeric value only, because you are not going to mention somebody's name in a price column. So you can put this restriction that it has to be a numeric value only, so that someone incorrectly doesn't put wrong data in the column. So some of the constraints are column level constraints like this, and some of the constraints are table level constraints that limit the whole table data. Okay, so some examples, say not null. If any column cannot be left null, there should always be a value, right? Unique. All the data entered in this column should be unique. For example, ID column. Okay, primary key. Now, most of the times ID becomes the primary key as it uniquely identifies each row. Then we have similarly foreign key. What would be the foreign key for a particular column? Then if some explicit check you want to apply on a database column, you can use check. If you want to give some default value to a particular column, you can use default. All these commands are the commands that are used to limit the data or constrain the data that you put in your database. All right. So with that note, we are done with the session for the day. We saw the 6 important things that were to be there to discuss on database. Kind of just an overview and a detailed understanding of how a database should be, what are the major points that you always should remember about a database. And basically, this is all what a database is about. So these 6 topics, if you master, you have nothing else to fear about when it comes to database management system. These 6 topics are your, holy grail topics for anything that is related to database. All right. So starting from the asset properties, the type of SQL statements that are there, then we have ER model. Similarly, you can maybe refer to relational schema as well. We have normalization, which is a very important point of any database management system, how to normalize your data, which form to use to normalize your data, right? And we have SQL joins. When there are multiple tables involved, you need to find a way to join those tables to get the right output, whatever you are looking for. So SQL joins is then the 5th most important or the most widely used or the most asked question in interviews or written examinations. And then we have SQL constraints, because you cannot leave your database open for everyone to do whatever they want. You have to at some point of time constrain it in a way that you can say, okay, this particular column I only want so and so data to enter, I don't want all other random data to enter in it, right? You can put a check saying that all the values in this column have to be unique. There cannot be 2 rows in this table that have the same value for this column, right? So all these checks can be put into your databases. These are the 6 topics that are the most important topics or the most widely asked topics in written examinations or interviews. All right. So yeah, asking differences between primary keys, candidate keys, foreign keys. Right, okay. Since you still have many queries, let me say next Thursday, let's do a detailed discussion on primary keys, candidate keys. There's not much to discuss, but anyways. And then we'll talk about normalization. So we'll start with the 1NF, 2NF, move on to BCNF and all those details. So next Thursday, the topic of discussion would be normalization. Say important interview questions on normalizations after discussing normalization in detail. All right. And then we'll address all these queries as well on next Thursday. Cool. So have a nice day. I hope you learned a lot in this session. At least you got to know what you have to focus on and how to, the most important point is how to relate to whatever you are learning to real life situations. So try to, like I said at the beginning of the session, go back, think of examples, try to relate all these concepts that we have talked about today to real life examples. Say atomicity in Uber case, or let's say data normalization in the case of Redbus, right? Try to come up with some ideas, think of some ideas and see how you can put the topics that we have discussed today to the real life cases. All right, I'll see you next Thursday and we'll talk more about, like I said, normalization and the keys. Cool. Thank you so much guys for joining me. Bye bye. I'll see you next time.